So I talked about polarity and how polarity leads to hydrogen bonding. And now I want to go over the 4 properties that result from hydrogen bonding. The first one is cohesion. Now I've given you the translation from the ancient Greek or Latin roots, and hesion means to stick, co means together. Whenever you translate scientific words, you always go from right to left. You read backwards, you translate it backwards. So it means to stick together. And so this is what I was talking about in the previous video. Like dissolves like, polar likes polar. So when you have a bunch of water molecules together, they're going to, let me go to my, download some pictures. Here is a beautiful picture of how, cohesion works. You look at the picture and you see these beautiful, almost perfectly spherical droplets of water. And why do they form this shape? Why aren't they more flat? Why aren't they like pointy? Why are they always round, these perfectly round droplets? And the reason is cohesion. Water droplets or water molecules are all polar. Air is made mostly of, let me go to a new page. Air is made mostly, I might as well just keep it red, of nitrogen is about 78% nitrogen, oxygen is about 19%, and the other 3%, my mental math not so good, is other. So nitrogen, 100% nonpolar, oxygen gas, 100% nonpolar. So you're talking about 97% of the air being nonpolar. And you've got water, which is polar. So water, liquid water really doesn't like the air because polar doesn't like nonpolar. So the water molecules are going to pull themselves together into a shape, which gives the least amount of surface area touching the nonpolar ickiness in the air. And so that shape happens to be a sphere. The same thing with, if you forgive me for having to do a Google search for a second, water on leaves. If you look at water on leaves, yeah, look at those gorgeous, gorgeous droplets of water. And so again, this is a really good example because you might think, well, why are they forming perfectly spherical drops? Well, now you should know that a sphere gives the least amount of surface area touching any other substance. I don't know if I explained that right, but yeah, it's like a small surface area compared to volume. And so if you know that water is polar, then that means that something on the leaf is nonpolar. Haha, you would be correct. Because it turns out that on the surface of leaves, they are covered with a kind of a wax. And one of the things you'll be learning very soon when we learn about lipids is that a wax is a type of fat. Well, kind of. The fat and wax are related. You've ever had a wax candle? Try washing it with water, okay? Water just forms little beads and falls off because wax is non-polar. So again, you have these gorgeous, 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 perfect little spheres of water that are forming on the surface of leaves because the leaves are covered with a non-polar wax and water's polar. So that is cohesion. Another way that you can experiment with cohesion by yourself is get a glass of water at home, fill it all the way to the top, and then slowly add, like drop by drop by drop, more water. You'll see that you'll be able to add, even though the glass is full, you'll see that the water on the surface doesn't stay flat. It actually starts to bulge like this until finally the weight of the water sticking to the top because of gravity finally pulled it over the side. But you see that water building up, building up, building up. That's cohesion because the water really likes itself. They like to stick together. That's cohesion.